and you can confirm or reject. Now in here, there's a lot of data, right? If we go to data, it looks like MetaMask was smart enough to know that this is calling a fund function, but it's having a hard time knowing what is actually happening. But we can see the raw transaction data in this hex section of the transaction. And then of course we can see 0.1 Go or Ethereum, the value being 0.1, right? So this should be the fund function. And we can actually verify that this is indeed the fund function by using the cast command to verify this data. So here, now I'm going to be teaching you a little introduction to function selectors. And we're going to talk about this a lot more later on. But the important thing to know is that in our contracts, all of our Solidity functions get transformed into this thing called a function selector. And like I said, we'll learn more about it a lot later. But if we go to our function fund, this needs to get broken down to some low-level bytecode, right? And when we send this transaction, we need to convert this human-readable fund into the actual bytecode, the actual EVM low-level code for Ethereum to understand what function we're actually calling. So what MetaMask actually does when calling this fund function is it converts it to its function selector. And we can actually find the function selector ourselves by using a cast command. So we'll run cast sig, which stands for signature, fund like this, and we'll get an output like this. This means the function signature fund returns the function selector this. And again, don't worry about these terms right now. We're going to explain them in depth much later, and this will make sense much later. But what we can do is we want to make sure that this website that we're using isn't calling a malicious function, right? We want to make sure it's actually calling the fund function. So we can run this command, get this function selector, and then go check out the hex here and say, do these actually match? So I can actually copy this hex data. Maybe I'll drop to the bottom of this, paste it here, and we'll grab what it should be here, and boom. Okay, great. These do indeed match. If I were to, for example, reject this transaction, and I'm going to go to our constants, I'm going to update this fund function from fund to steal money. Let's say there was another function called steal money, right? I'm going to go ahead and save this. Cast sig steal money would have a different what's called function signature. And again, don't worry about it too much, but it just has a different like low level hex encoding of this. So now if we change this to steal money, and maybe the website was malicious, and instead of the fund function calling fund, it called steal money instead, we would want to make sure that we're not calling this steal money function. So if I refresh the front end, I'll put 0.1 in here, I'll hit fund. If we go to the data, if we go to the hex, what we can do then is we can copy this hex, bring it back to the bottom, paste it in here. We can say, oh, it looks like this is the function that our MetaMask is calling, and we can run cast sig steal money like this and see, oh my goodness, our website is actually calling the steal money function and not the fund function that I want it to be calling. So this is a taste of how we can actually verify the transactions that we're calling. Now, if this has function parameters, we can do this thing called call data decode. So these are functions that don't have any parameters, right? Fund and steal money both don't have any parameters. If they did have parameters, this hex data would be a lot bigger, right? Because we'd have to send a lot more data to call the function. So later on, when you want to verify a transaction that has parameters, what you do is cast -- call data - decode. You'd paste the data. Actually, let me see what this does. It goes sig call data. So you do cast -- call data decode. Maybe something, paste the signature, paste the call data. And if there are parameters in here and parameters with the call data, it would tell you what each parameter of this function is. And this is not a great example because there's no parameters in here. But like I said, you'll learn about this methodology later. So I just wanted to introduce it to you here that when you are sending transactions in MetaMask, you are going to be the developers. You are going to be the ones smart enough to know how to actually decode them. Like I said, we'll go in depth more with that a little bit later. But I'm going to go ahead and reject this for now. We're going to go back to our constants. We're going to change this back to fund. We're going to refresh. We're going to go back to index, and we're going to steal money. We're going to change this back to fund like this. Okay, great. So now if I go ahead and refresh now, I put 0.1 in here, I hit fund, MetaMask is going to pop up. I can go to hex. I can see this here. I can go down. I'll do cast, I'll clear. I'll do cast sig fund like this. I'll see that I'm expecting to call this function here. So I'll paste this here. Then I'll go to my MetaMask. I'll copy this. I'll see if they're the same. And sure enough, they are. Okay, great. So now though, I'm going to go ahead and hit confirm. And when we hit confirm, our MetaMask is actually signing this transaction and sending the function via that API call, right? That 127.0.0.15500, that RPC URL that we gave it for Anvil, right? And if we're on a mainnet or testnet, it's going to be that Infura endpoint that comes built into MetaMask, right? But now that we've sent it, we can actually call get balance now. We can see the balance has indeed increased, right? The balance has upped. What I could do now is withdraw, as we know. We go back to our Foundry Fund Me. We go to SRC, go to Fund Me, we go to function withdraw. We know that this is an only owner function. So if we go back to our application here, calling withdraw from the owner will of course work. But if I switch, let's go ahead and switch to a different account. Let's go ahead and we'll send some money between our accounts. We'll send some money to account 3, send maybe 100, doesn't really matter. We'll go ahead and confirm this. And this is sending, of course, on our Anvil chain, right? Because that's the one that we're on. Now, if I switch over to account 3, which now has 100, I'll connect to my account 3. If I try to call withdraw, we're going to get this RPC error, right? Execution error, right? Call withdraw. Maybe we'll go ahead and refresh. Are we still on account 3? We sure are. Withdraw, we're getting an error, right? Because it's only owner. But if I switch back from Anvil, from account 3 back to account 4, now we're connected via account 4. I'll call withdraw here. We'll see MetaMask does indeed pop up. If we go to the hex, we can see this hex here. I'll pull up my MetaMask to make sure. I'll do cast sig withdraw. Okay, great. This is the hex for our withdraw function. Those look like they're the same. Awesome. So I can have some assurance that I went ahead and confirm and call this withdraw function. So we're going to get that 0.1 out. Remember before, the balance was 0.1. Once this finishes mining, the balance will go back to 0. And sure enough, that's exactly what we see.